Hi students, I am Dr. Priya V.S., Associate Professor, Department of Civil Engineering from School of Infrastructure. The course title is Water and Wastewater Engineering. And in today's discussion, we are going to deal with water supply engineering. So let's start. So what is water? Water is the elixir of life. We all know the major process that is involved with the water in the atmosphere is the water cycle. So what are the three main processes that is involved in the water cycle? Initially, the water from the different sources such as ocean, river and various other lakes and ponds, they evaporate depending upon the temperature, and further from the evaporation, when they reach the atmosphere, they condense and subsequently fall as rain in the form of precipitation. Yes, now we can understand what are the different types of sources of water that is there in the earth. Yes, so 96.5% of water is available in the form of oceans, which we cannot directly depend upon as water supply, and we are only left with 3% of water which we are to deal with. Yes, now this 3% of water is available in the form of different sources. They can be broadly classified under surface sources and underground sources. So to quote few examples for surface sources, it can be a reservoir, river, lake, stream, springs, and the main underground is water supply is through the wells. Next is, where do people get water actually from? Yes, though there might be lot of sources, we mainly depend upon for our water supply through public taps, which is around 25%, followed by bore wells, then piped water, and subsequently by open wells and rivers. Yes, so these are the different sources actually people get water from. So coming on to water supply engineering, the two main essential components that is involved in water supply engineering is population determination and rate of demand. It is essential to forecast the population correctly and also to have a clear knowledge on the various rates of demand. Yeah, what is the water demand? Actually, an average consumption by a person varies from 3 to 6 liters per day. The total water requirement which we demand in a day, it can be broadly classified under various categories. So first one is residential or the domestic use, then comes the institutional use, third is the public use, fourth is the industrial usage, and fifth one is the water system loss. Now let's go one by one. So first, coming on to the requirement by the residential or the domestic use. As per IS 1172/1957, it recommends a per capita consumption of 135 liters per day. So how does this 135 liters per day comes in? It can be broadly divided into various activities such as bathing, which requires around 55 liters per head per day. Usually the amount of water is always quoted as liters per head per day. So washing of clothes, you require 20 liters, and flushing of water closets, it requires 30, washing the house 10, washing of utensils 10 liters, cooking, drinking 5 liters per head per day. So it constitutes around 135 liters per day. Not only humans, even animals require water. According to the Manual on Water Supply and Treatment prepared by the Ministry of Urban Development, New Delhi, it recommends the following rates. So consumption of water for the domestic animals, for the cow and buffalo, it varies from 40 to 60 liters per animal per day, and from horse it is around 40 to 50, and dog 8 to 12, followed by sheep and goat 5 to 10. So this is with respect to the animals. Next demand is from the institutional use. Institutions, there are several institutions around us. It can be a hospital, it can be a hotel, it can be a hostel, it can be a nurse homes, or it can be a boarding schools. So various demands are being exerted by these institutions also. So if you look at the requirement, so water requirement is liters again per head per day. So for hospitals, if it is around 340 per bed, if the number of beds not exceeding 100, and if the number of beds are exceeding 100, it rises up to 450 per bed. Coming on to hotels, it is 180 per bed. Then followed by hostels, it is equivalent to that of the average demand, that is around 135 liters per day. And boarding schools, again 135 liters per day. And apart from that, we have restaurants, airports, seaports, junction stations and intermediate stations, terminal stations. These stations not only include the railways but also the airports, stations and also the bus stations that requires around 70 liters per head per day. In day schools and colleges, around 45 liters. Offices around 45 liters, factories again 45 liters per head per day, and finally cinema, concert halls and theaters around 15 liters per day. So these are the institutional uses. Coming on to the third major requirement, it is the public use. So public use, water is required under the following purposes. It can be a road washing, it can be for the sanitation purpose, it can be for the watering of the public parks and for the firefighting. So on average basis, road washing, the consumption is around 5 liters per head per day, and for the sanitation it is around 3 to 5 liters per head per day, and public parks again it is based on the per square meter per day. Now the major demand is in this public use is the fire demand. So fire demand depends upon the population, the congestion and the fire resistance of a particular building. So fire hydrants 15 to 20 centimeter in diameter should be provided on the street corners to fight the fire, and the water pressure that should be available within the fire hydrants should be around 1 to 2 kg per centimeters in order to fight fire. The fire has to be fought with at least 3 streams of jet, which is carrying a capacity of 1,100 liters per minute, and this has to go for an hour of 3 to 5 hours in order to put down the fire. Next comes to the industrial use. The quantity of water that is required for the industries varies depending upon the process, and it varies from industry to industries and also depending upon the unit of production. Here are few examples and the industrial needs given in this table. For example, if it is an automobile industry, depending upon the vehicle production, you have 40 kiloliters per unit. Similarly, for a textile industries, for a production of 100 kg, you need around 8 to 14 liters per 14 kiloliters per unit. And again, paper industries, if you can see, per ton of unit production you have around 200 to 400 kiloliters per unit. Again, I'm telling it is depending upon the type of the industry and what is the process that is carried out in the industries. And apart from these demands, water is also lost from the systems. So where does all these losses take place and why should we account into? Usually the losses are because of the leakage and the overflow that happens in the service reservoirs, and there can be leakage in the main and the service pipe connections. You cannot avoid the leakage also from the wastage from the public taps and due to defective joints, cracked pipes, loose valves, etc. So water system losses should also be considered into the total water requirement. Now coming on to the per capita demand, based on the categories what we have previously discussed, can be a domestic use, industrial use, commercial use, public use, waste and thefts, etc. You have a total demand of 335 liters per head per day. So the total yearly water requirement of the city in liters divided by the per year, calculating into the design period into account, you call that as the per capita demand. Now coming on to the factors that will affect the rate of the demand. So we have discussed about 335 liters. What are the factors that is going to affect these rates? It can be a size and type of the community, standard of living, how standard of living is going to affect. If you have a very high standard of living, you expect a good hygiene and there is consequently a good use of water. Climatic conditions, quality of water. If the quality of water is good, we tend to use more water. Pressure in the supply system, system of supply, metering, water rates and age of community. If it is a stable community, then they require much less water when compared to a newly developed community. Then followed by the variation. Though the variation in the season, it may vary. Let's look into the hourly variation. This is a graph representing the hourly rate of water requirement Now, how does the water requirement vary per day? Initially, during the early hours, that is starting from 2 to 6 o'clock in the morning, there is a very gradual rise in the water demand. Most of us are sleeping during that time, and when it comes to around 8 a.m., there is a rapid increase in the water, and it goes around 35 liters per hour. Yep. So after that, around 12 o'clock again there is a gradual decrease, and after in the early night times around 8 o'clock there is again a demand. So this shows that a variation in the hourly basis, the requirement of water what we take up during the different hours of the day, and 20 liters is the average demand that is exerted by an individual. Design period. The future period, or the number of years for which a provision is made in designing the capacities of the various components of water supply scheme, is known as design period. This is required when we design each and every component of the water supply system. What are the factors that is governing the design period? Number 1, it is the useful life of the component structures. Number 2, ease and difficulty in expansion of the work. Number 3, availability of investments. Number 4, rate of interest on borrowing. And number 5, the anticipated rate of population growth. Now let's discuss what are the different components are there in the water distribution system. So first one, it starts with the storage, then followed by intake works, pump houses, water treatment units, pipe connections to the treatment units and small appurtenances. Then you have raw water and clear water conveying units, reservoirs, distribution system. These are the components that is involved in the water distribution systems. So, and what is the design period in years? So for the storage by dams, you have to take up a design period of 50. Intake works, it is around 30. Pump houses, 30. Water treatment units, it should minimum serve the community for a year of 15 years. Pipe connections, it should be around 30 years, and conveying units 30 years, reservoirs 15, and distribution system should serve around 30 years. Now, whatever water we collect, how do we drink? What is the process that is involved in treatment of this water? Let's look at this diagram. This will give you a small picture about the various treatment units that is involved in the water treatment plant. So let's consider an example of a surface water source. It can be a lake or a river. Usually there is an intake structure that is constructed in a lake through which the water is collected from the surface source. From the intake water, from the intake structures, the water is taken to the first unit that is called as screens. Screens, the main purpose is to remove the floating objects. If these floating objects are not removed, they can further go and interfere with the other treatment units, and also cause disturbance to the functioning of pumps in the treatment units. So we need to remove those floating objects, and hence we provide screens. Followed by screens, the water is falling to the different units. First one is the coagulation, followed by sedimentation. These two units are aimed to remove the suspended and the colloidal particles that is there in the water. The suspended tanks will remove particles which will settle on its own gravity. Such particles are called as discrete particles, and such settling is called as discrete settling. And for the colloidal particles, they always carry a charge, so they repel from each other. So to destabilize them and make them settle down, we are employing an additional agent. It could be in the form of a coagulant. The common coagulants that is used are alum and ferric. Alum tries to bring about the charge neutralization of these colloids. After charge neutralization, they are subjected to a process called flocculation, where these colloids are made to combine, increase in the density by forming flocks, and subsequently settle down at the bottom of the tanks. After these sedimentation and coagulation unit, the water is sent to a sand filtration system. There are two types of sand filtration system. It can be a slow sand filter or it can be a rapid sand filter. But the basic mechanism is when the water is subjected to sand filtration, it undergoes mechanical straining. There can be small sedimentation through the sand, and subsequently the particles, suspended particles, impurities are all removed by the sand filtration. And from this sand filtration, the water is taken to the chlorination unit, where the chlorine is added. This ensures that the water is safe till it reaches us. So chlorination is one form of disinfection that has been employed in the water treatment system. From the chlorination unit, the water is taken to the elevated storage facility and it is subsequently distributed to the city by gravity.